Suppose you're given 1, radical 3 rectangular, and you're trying to change this into polar. What do you do? In this case, you use the formulas r equal to x squared plus y squared, square root, and theta equal to tangent inverse of y over x plus alpha. And you need this plus alpha because tangent inverse can only produce numbers in here. So if your number, if your point belong to the first quadrant or the fourth quadrant, it's okay. So in that case, alpha is 0. You don't add anything. However, if your point happens to belong to the second quadrant or the third quadrant, you have to modify your answer by 180 because this will not be able to produce that number. Okay? And the convention that people usually use is to add 180 in the second quadrant and to subtract 180 in the third quadrant. Okay? This is especially true when you're using the tangent inverse in your electrical engineering course, when you talk about how the current follows the voltage and so and so. Okay? So please try to use this convention whenever you can. Now in our case, x and y are both positive. What does that mean? You're in the first quadrant, and therefore you're not adding anything. All right, so let's compute this. So in our case, r is square root of 1 squared plus radical 3 squared, which is square root of 4, which is 2. So the radius, the distance from the origin is 2. And for the angle, theta is tangent inverse of radical 3 over 1 plus 0. We agree that it's 0 because it's in the first quadrant. And tangent inverse of radical 3 is 60 degrees. If you convert this into radius, it's 5/3. When you write degrees, please put this small circle because if you don't have that circle, it means it's radians, and it's funny to say that number 60 is same as pi/3, which is not true. Okay? You really need that degree symbol to make things right. Okay, let me give you another example. What if you had -1, 1, and you wanted to change to, and let's say this is rectangular, and you want to change it to polar. Okay, you get r again by calculating -1 squared plus 1 squared, which is square root of 2. And for the angle theta, because this is now in the second quadrant, right? 1, 2, 3, 4. It's in the second quadrant because x coordinate is negative and y coordinate is positive. So you're here, therefore, what do you have to add? 180 degrees. So you have to do tangent inverse of 1 over -1 plus 180 degrees, which is tangent inverse of -1 plus 180 degrees. And another nice thing to know is that if you have tangent inverse or sine inverse, the negatives can come out. And then we know what tangent inverse of 1 is. That's 45 degrees. Okay? And therefore, this is -45 plus 180. And if I write it in terms of radians, this is 3 pi. Therefore, the answer is, oh, even this one I forgot to write down the answer. So for this one, what's the answer? This is 2 pi over 3. This one. For this one, what's the answer? It's radical 2, 3 pi over 3. Now, in some cases, we can't determine the angle exactly because your numbers are not given in the way that the angles come out as special angles. In that case, you can only work with tangent inverse function. So think about this example: -3, -4, rectangle. How do you change this into polar? Well, r is equal to square root of negative 3 squared plus negative 4 squared. That's square root of 25, which is 5. Or you might recognize the 3, 4, 5 triangle, right? But which quadrant is this in? 1, 2, 3, because they're both negative. You're in the third quadrant. Therefore, if you want the angle theta, you have to do tangent inverse of negative 4 over negative 3 plus, actually, you have to subtract 180 degrees, right? Or you have to subtract pi if you write radians, okay? And this is none of those special angles. We only know the tangent inverse of 1, tangent inverse of radical 3, and tangent inverse of 1 over radical 3. Those are the three special angles that we know. The other cases we don't. So there's no choice but for us to just write it as 4 over 3 minus pi. Of course, if we had a calculator, we can actually calculate this, but we're not allowing calculators in the exam, so you just have to leave it like this.